Hi, today we're going to talk about compound interest and what the formula looks like and what the formula means. First off, let me show you a basic interest, or actually not even an interest, an exponential formula. Remember that all exponential functions model this equation, y equals a times b to the x. We've talked about the fact that this is your initial value, this is going to be your rate, and then this is your time. Of course, y is your answer. Okay, so if I apply this to an interest problem, what I can tell you is this amount as a function of time is the answer, or the amount in your account. P represents the principal amount, or the invested amount, how much you're putting into the bank or into the investment. R, the base, it represents the rate. And T, of course, is time, typically the number of years that the investment will last. Over here, I reminded you that that rate comes from adding 1 to whatever the percent interest rate is, whether it's 5%, 4.25%, whatever it happens to be. Hopefully it's a growth, not a decay. We invest our money so it grows. So let me just define those over here. The amount is a function of time. Keep in mind this is function notation. This is basically the answer, or the amount in the account. P represents the principal. Which is how much is invested in, how much you put into the bank or into the investment. And of course, R is the rate and T is the time. Okay. So let me just throw an example down here quick, just show you something easy. Okay, so here's an example, and again, I rewrote my formula, or my model, that's a parenthesis there. The amount as a function of time is equal to the principal times the rate raised to the time. If I wanted to invest $1,000, this becomes my principal right here. So I will put that equals P. At 3.5% interest is my rate, so I'm going to add that to 1, and my rate will become 1.035, and this, of course, is my time. Okay, so when I substitute, I will get the amount at 1 year, because that's what my time is, that's the time, is equal to $1,000 times 1.035 raised to the first power. And of course, when you put that into your calculator or whatever, you end up with $1,035 at the end of that year. Okay, so that's if they calculate the money at the end of the year. If I were to do it for a second year, then this becomes, right here, this becomes the money in the investment, and then this would get multiplied by 1.035 in the second year. Okay, so that's why this is exponential, because each year you take what's there and multiply it by that rate again. So pretty soon your interest, the money that you earned, also starts to earn interest, which is where the compounding comes into play. And we'll talk about that a little bit more in class tomorrow so that it's more clear. Right now I just really want to get these formulas into your notes and show you how they work. So I'm going to use the same investment of $1,000 at 3.5%, but this time I want to invest it for 7 years. So now I'm asking you to find the amount after 7 years. You start off the same way. The initial amount doesn't change. It's still $1,000. My rate would be 1 plus my percent as a decimal, which is 0.035, and then that's going to be raised to the 7th power. Punch that in your calculator and you'll get a grand total of $1,272.28. You always want to make sure you round it appropriately to money, so to hundredths. So the question here becomes, what does compound mean? When they talk about compounded interest, what does that mean? Basically what it means is that your interest starts to work for you too. So every time you earn some money through interest and it gets added to your account, that starts to collect interest as well. So one of the things that you need to realize is that to only get the interest at the end of the year is very unusual, Banks don't do that. If you put your money into an account, and let's just say for instance that it were to earn 4% per year, which is a little high these days. Didn't used to be, but now it is. But just for giggles, we're going to talk about 4% per year. Okay? What you need to realize is that the bank doesn't take your money and at the end of the year add that interest. Although you probably could find an account somewhere that would do that. But what we discover is that the more we actually calculate that interest and add it on, the quicker our money will build and the quicker our money will start to work for us. And that's the key to compounded interest, is getting that money in little chunks instead of one big chunk at the end of the year. So here's what I need you to understand. If you were to take that 4% and compound it annually, then at the end of the year, you would take your principal and you would multiply it by your 1.04 and raise it to however many years you are going to calculate that for. However, let's say I tell you that I'm going to take that 4% and I'm going to compound it quarterly. Quarterly means four times per year. And so what happens is they're not going to give you 4% 4 times a year, because that's going to ultimately be 16%. So what they do instead, quarterly, they take that 4%, which is 0.04, and they'll divide it by how many times per year they're going to calculate your interest. So at the end of March, at the end of June, at the end of April, and at the end of March, at the end of June, at the end of September, and then again at the end of December, they would give you 1%, 1%, 1%, and 1%. Now you might not think that that is going to make any difference. However, in the long run, especially as your principal and your balance gets bigger, it makes a huge difference. And so I want to show you the difference between these two calculations. We're going to do 4% annually, and then we're going to do 4% quarterly. Okay? Just so that you can see the difference. I'll do it on $1,000. Okay? So I'm just going to say the amount is going to be equal to $1,000. My rate would be 1.04. And let's do this over 5 years for both of these, okay? Just for giggles. So I'm going to raise this one to the 5th power. And I'll tell you that the amount is equal to $1,216.65. Now over here I'm going to do this quarterly. So keep in mind I'm only going to add 1%, but I'm going to do it 4 times per year. So my amount is going to be equal to the $1,000 that I'm starting with. Here's the thing. The 1% comes from taking the 4% and dividing it by 4. So this time I'm going to multiply it by 1.01. But over 5 years, I'm going to actually be compounding this thing 20 times, because I'm going to add that interest 4 times a year over 5 years. So I'm going to multiply that together. And when I put this in my calculator, I'm going to put it in as 1,000 times 1.01 raised to the 20. As you can see, the total amount of money in my account at this point is $1,220.19. That's about $4 more than what I would have had I only done the compounding once a year as opposed to 4 times a year. Now you might not think that $4 is that big of a deal, but trust me when I tell you that this money adds up quickly. This is simply doing nothing more than compounding it 4 times a year as opposed to once a year. Well, then you say, well, if quarterly is good, once every 3 months, then why not monthly? What happens if they add the interest monthly? Which is typically what a bank will do. If you put your money into a savings account, you get your interest at the end of every month. Monthly means 12 times a year. So again, what would happen is that 0.04, which is my 4%, would get divided by 12. And if I do that real quick on my calculator here, I can tell you that my interest rate is approximately 0.0033333, repeating. Now, you know my thoughts on repeating decimals, so I don't have to go there with you. And we don't really want to round this because with exponential functions, rounding can be very detrimental to the accuracy of our problem. So I really, instead of using this format for the rate, I'm going to use this in its entirety and let the calculator just use the whole decimal. All right, so let's think about this then. Because if we go back to the original problem, the amount is equal to the principal, which is what you're putting in. For this case, it's $1,000, times the rate, which is 1 plus the rate raised to the time. So this is where the bank account rate came from. So when it was 4%, it was 1.04 because I added the 0.04 to the 1. But keep in mind where this rate comes from now. This rate comes from taking whatever the decimal is, whatever the rate is, and dividing it by the number of times per year you're compounding. We call that n. Okay? So we're introducing a new variable here, n. And n is the number of times compounded or calculated per year. Okay, that's an important one to remember. So if you think about how this was figured out then, this 0.0033333333, what I will tell you is the amount will be equal to the principal, which is what you're putting in, and to the 1 you're going to add this decimal piece, but I'm going to add it in a little bit more exact detail, which is the rate divided by n, how many times per year. Then that's going to be raised to the number of years. But remember, when we do this for 5 years, if I'm compounding it 4 times a year, that's 5 times 4. If I'm compounding it 12 times a year, that's 5 times 12. So I need to multiply the number of years by how many times per year it's compounding. And then this becomes the formula that I'm going to use for compound interest. So if I go back and do my $1,000, 1 plus, I'm going to use the 0.04 over 12. That will ultimately give me the 0.0033333333 raised to the nt, which in this case is 12 times 5, or 60. I'm going to go to my calculator. You can see here that my total is $1,221. Not as big of a jump going from 4 times a year to 12 times a year. Remember, 4 times a year was at $1,220.19. This was the amount after 4 times a year. So, and this is 12 times per year. Okay. Okay, so this is the formula that I need you to get into your notebooks. This is a really important one because the Regents this year, they do like to use this. Compound interest, A, stands for the amount, is equal to P times 1 plus R over N raised to the NT. And again, A stands for the amount in the account, P is your principal, R is your rate, N is the number of times compounded per year, and T is the number of years. So the piece that gets added that's new here is this N. And N represents, again, the number of times compounded per month. Now, I cannot guarantee you that they will give you this formula on the test. Typically, they do. But what I will tell you is that you are responsible for knowing what each of these variables represents. So you need to know that this is the answer, this is the amount in the account, and this is the principal, which is the initial value. You need to know that R represents the rate, and that N represents the number of times compounded per year, T represents the number of years. I'll tell you that most people don't have a problem with any of these variables except for N. N is the one that they tend to forget about. So you want to make sure that you pay extra focus to this one right here, because that's going to tell you, how many times, basically the number of times per year tells you what to divide the rate by so that you know how much you get each time. Right, now N can be anything from, if it's annually, N is 1. If it's semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. I could do daily, N would be 365. Okay, so as long as I can count N, which is the number of times per year the compounded interest is calculated, this is the formula I use. Tomorrow we will talk about what it means to be continuous and what the formula for continuous interest looks like. All right, so when you come to class, we'll practice a couple of these just on the calculator just to make sure that everybody's got them, the process for putting it into the calculator correct. But we're really going to look at continuous interest and what that means. Okay, that's all. Good night and see you tomorrow.